video, what we're going to talk about is monitoring climate change through temperature and rainfall data. And so it's going to be seasonal decompose. And we're going to do this by creating a program in Python. And the first thing that we're going to do when we create this program in Python is to import 4 libraries that you're going to need to execute the program. So the first library we're going to import is NumPy as NP, which is a numeric library, but it also creates NumPy arrays. The second library that we're going to import is Pandas as PD, which is a data processing library, but it also creates data frames and series. And then we're going to import matplotlib.pyplot as PLT, which is a visualization library. And from statsmodels.tsa.seasonal, we're going to import seasonal decompose. So statsmodels is Python statistics library. TSA is time series analysis module within the statistics library. And seasonal is a module within the time series analysis. So now what we're going to do is we're going to generate synthetic monthly temperature and rainfall data for a period of 10 years. So the first thing in that regard that you want to do is you want to set your seed. The reason why you set your seed is so every time you run the program, it initializes to the same values. So you set the seed by typing np.random.seed brackets, and then you can put any number you want in the brackets. And then we define the variable of months equals pd.daterange bracket start equals 2013-01, comma, periods equals 120. So that's 10 years, 10 times 12. Frequency equals m. So you're going to have 10 years of data. So now we're going to simulate the temperature data. So temperature trend equals 0.02 times np.arange ln months. So that's going to be 120. And the temperature seasonality equals 5 times np.sine brackets 2 times np.pi times brackets months.month divided by 12 brackets. So that's your seasonal temperature variation. And then temperature noise equals np.random.normal brackets 0, 1, ln months. So that's 120. So that's your random fluctuations. And temperature data equals 15 plus temperature trend plus temperature seasonality plus temperature noise. So that's the combined temperature data. So now what we're going to do is we're going to generate some simulated rainfall data. So rainfall trend equals negative 0.01 times np.arange brackets ln month, which is 120. So you're having a gradual decline in rainfall. Rainfall seasonality equals 20 times np.sine brackets 2 times np.pi times brackets month.month divided by 12. So that's going to be 10 years. That's seasonal rainfall variation. Rainfall noise equals np.random.normal. Normal is your normal distribution. Bracket 0, 5, ln months brackets. So that's your random fluctuations. And rainfall data equals 100 plus rainfall trend plus rainfall seasonality plus rainfall noise. So that's combined. So now what we're going to do is we're going to create a data frame for the time series data. So climate data equals pd.dataframe brackets, curly brackets, month, months, comma, temperature, temperature data, comma, rainfall, rainfall data, curly brackets, and then brackets. And then we're going to set the index so that the month is the index. So climate data dot set index brackets month comma in place equals true. So basically your index is your month, and then your first column is your temperature, and your second column is your rainfall. So now what we're going to do is we're going to decompose temperature and rainfall data. So temperature decomposition equals seasonal decompose brackets climate data square brackets temperature comma model equals additive comma period equals 12. And then rainfall decomposition equals seasonal decompose comma climate data square brackets rainfall comma model equals additive period equals 12. So now we're going to plot the decomposition. PLT.figure brackets fig size equals 6, 4. PLT.subtitle brackets temperature and rainfall decomposition font size equals 16. So now we're going to plot the temperature decomposition. PLT.subplot brackets 2, 2, 1. PLT.plot brackets climate data dot index comma climate data square brackets temperature comma label equals observed temperature comma color equals red. PLT.title is observed temperature, and then you get a grid. So we're going to PLT.subplot brackets 2, 2, 2. PLT.plot brackets temperature decomposition dot trend comma label equals temperature trend comma color equals orange. PLT.title is temperature trend. PLT.grid is true. So now we're going to plot the rainfall decomposition. PLT.subplot brackets 2, 2, 3. PLT.plot brackets climate data dot index comma climate data square brackets rainfall comma label equals observed rainfall color equals blue. The title of that is observed rainfall, and then you also get a grid. So you have PLT.subplot brackets 2, 2, 2. PLT.plot brackets rainfall decomposition dot trend comma label equals rainfall trend comma color equals green brackets. The title is rainfall trend, and then you get a grid. So PLT.type layout brackets rect equals square brackets 0, 0, 1, 0.96, and then you're going to show it. You're going to show the graph that you've made. So now we're going to plot the temperature and rainfall trends over time. PLT.figure brackets fig size equals 6, 4. PLT.plot brackets climate data dot index comma climate data square brackets temperature square brackets comma label equals temperature in Celsius comma color equals red. PLT.plot bracket climate data dot index comma climate data square brackets rainfall square brackets comma label equals rainfall in millimeters comma color equals blue. PLT.title is temperature and rainfall over time. X label is date. Y label is value. You get a legend, you get a grid, and then we're going to show it. So this is it. This is what the graph that we have made. So you have observed temperature over time. So that should be 12 years or 10 years. And then you have a temperature trend where the temperature is gradually increasing. And then you have observed rainfall over time. And then you have the rainfall trend where it is gradually decreasing. And then you have temperature and rainfall over time. So the temperature is red and the rainfall is blue. So the rainfall is gradually decreasing and the temperature is gradually increasing. So that concludes this video. In the next video, I will be covering another statistical subject. So I hope that you decide to watch it.